Alright, in the last video we talked about the idea of area between curves. And the way to do that is to represent these regions as an upper function and a lower function. However, part of doing that involves the definite integral, and definite integrals have bounds, so there's an a and there's a b. So we need to find what those a's and b's are. And we're going to use the examples that we developed in the previous video, or we're going to use them from the previous video, and we're going to use them as sort of our template for finding the intersection points. One a little bit of an easier example, one a little more difficult. So in the first case, what we have is some function x and some function x squared. We need to know where these two are equal to each other. So the way you do that is you set them equal to each other. It's pretty simple. You say, all right, x equals x squared. Now you might say, okay, well, where's that going to be true? So you could divide both sides by x, and you would get that x is 1. And that's great, grand, and wonderful here. And you probably could figure out what this is without thinking too much, but I wanted to point out this to show that this is this is one of those cases where you actually end up dividing out a solution. It's why it's not usually recommended to solve problems this way by dividing by x when you can help it. Usually factoring is a better solution. So let's do this by factoring. Let's do the same problem by factoring. We're instead going to say, if we subtract x from both sides, we get 0 equals x squared minus x, which then we can factor an x out, and we get x times x minus 1. Now, if we remember the zero product property, the zero product property says if two numbers are multiplied together and they equal 0, then the first one is 0 or the second one is 0. So you split these into two cases, one where you have x is 0 and one where x minus 1 is 0, which of course gives us the two solutions, 0 and 1. Those are our two solutions for this problem. Again, these are things you probably could have figured out fairly easily just from looking at the graph. But it's important to go through the process when it's simple, because now we have something that's a little less simple. So what we're going to do here is we're going to say, okay, I've got k of x equals the absolute value of x, and h of x equals 4 minus x squared. So those are my two crossover points. I have two crossover points for these two functions. And what I need to do is need to solve them. So in the first case, let's solve the case where we're on the positive side. We're on the positive x side. So let's not overthink this. We have to set these things equal to each other. We know that the absolute value of x is equal to 4 minus x squared. So that has, we can represent this as either the positive case for x or the negative case for x. Let's take the case where x is positive. So that's going to be x equals 4 minus x squared. Now if we add x squared minus 4 to both sides, if we add x squared, that's going to cancel this one, so we kind of move that over. We get x squared plus x minus 4 equals 0. Okay, so you might think to yourself, okay, I'm going to factor this. Well, good luck. It doesn't quite work out that way, so what we're going to have to do instead is use the quadratic formula. And if you remember, that's going to be, negative b, so that's a 1 here. So negative 1 plus or minus b squared, so that's 1, minus 4 times a, which is 1, times c, which is negative 4, all over 2a, like that. So in that particular case, what we're going to do is, 2a, a is 1, so that's over 2. So we have negative 1 plus or minus that. If we plug it in, we get negative 1/2 plus or minus square root of 17 over 2. I know I did a lot of work there, plus or minus square root of 17 over 2. So 1/2 plus or minus the square root of 17, or negative 1/2 plus or minus the square root of 17 over 2. Now, you have to think this through. You have to think, okay, which one of these solutions makes sense? And I'm going to go ahead and shorten this for you, and the answer is the case where this is a plus. Now you have to ask yourself, okay, why didn't we choose? It gave me two answers. Why can't I use both of them? Well, what we did is we assumed automatically from the start of this that x was a positive number. Remember, we made that assumption before we went and solved it. If we used the negative case, we would have arrived at a negative number, and that's impossible. So we have to discard the case that doesn't make sense for our assumption. So negative 1/2 plus square root of 17 over 2 is one of our points. Now, if we make the assumption that x is negative, then absolute value of x is negative whatever x is, right? Because if x is negative, then negative x would be positive, which is what the absolute value function is doing. It's the distance. It's a distance metric from how far you are. But nonetheless, the idea here is absolute value is, here, I'll just go ahead and write it. I'm saying more than I could easily cover by writing. Absolute value function is defined as x anytime x is greater than or equal to, it's equal to itself, just whatever was in there if that number is not negative, and it's the negative version is that. So challenge you, take this and kind of play with that. If you're having trouble with this definition, try to play with that. Plug in negative numbers. If I plug in negative 2 here, it should pop out a positive 2. Well, negative 2 is positive 2, right? Anyway, play around with that if you're having trouble. So if I take the case where x is negative, I get negative x is equal to 4 minus x squared. I get the same type of problem here. I just get x squared minus x minus 4 is equal to 0, which seems like a, oh, okay, this is pretty much the same type of problem. It is. So if we run the quadratic formula again, and I'll save you the heartache there, we get positive 1/2 plus or minus square root of 17 over 2. So again, we have plus or minus here, but we have made the assumption that x has to be negative. So we can't take the positive case. So we actually take 1/2 minus square root of 17 over 2. So this is our intersection point here. This is our intersection point there. And those are our two intersection points. So it's kind of nasty, right? That's not a really ideal situation that you want to have. The next little piece you want, right? So in this case, this isn't, I'm going to add a little more than what was asked for in the problem. They asked for the intersection points, but I want to go a little further. This region that's highlighted at the endpoints here, that's the whole region, right? I know an endpoint, that's A, this is B. But over here, that's not really true, right? I have some sort of strip where the region starts. So how do I find where that region is? How do I find, that the little loop over point? How do I find this? And how do I find that point? Well, in those cases, all we're actually trying to do is find cases where the parabola is equal to 0, right? They're striking the x-axis. So we need to let's go ahead and solve that. We're going to say, all right, where does 4 minus x squared equal 0? Where would that possibly be? Well, I mean, if we rewrite this, it's x squared equals 4, okay? And if x squared equals 4, then x could be positive 2 or it could be negative 2. So that tells me that this point is negative 2, this point is positive 2. And then it also tells me, don't know how I lost track of my green marker. It also tells me that this point is 1/2 minus the square root of 17 over 2. And this point is negative 1/2 plus the square root of 17 over 2. So that's kind of ugly, but those are your points, your crossover points. And now you actually have enough points to solve both these problems, but specifically this problem if you're going to do it with integration.